Hello and welcome to another tutorial of opens and shorts. Before we did it in very simple basic electronic circuits, today we're going to move on a little advanced to the actual circuit. Now the basic circuit that we did last time, just as a refresher, as a reminder, you start from the positive, you work your way around, and there's a switch. This switch has to be in the closed position. You see this symbol? That means it is closed, normally closed. So current flows from the positive of the battery through the switch, through one side of the bulb, comes out the other side of the bulb, and it has to return to the negative. It has to be a complete path. Now, you bring another, let's say this is the brake lights. You know there's two of them. Let's put another bulb. Now there are two in parallel. The same voltage that's at one is at the other one. If I had, instead of two, if I had 5 bulbs in parallel, they all have 12. If I have 8, if I have 10, if they are in parallel, they all have the same 12 volts. What happens if this opens up, the switch is open? How much will these measure? 0 volts. Why? We're not connected anymore to the battery. This is now open. If the wire over here is open here, after the switch or before the switch, how much will this measure? 0 volts. Why? We're not connected to the battery. Now, let's take it to a little higher, to a schematic. We're going to go over opens and shorts until we know it like the back of our hands. Okay. We start obviously in hot or run. That means we have to be in the hot position, in hot position, run position. So that means the fuse is here. This is a fuse, obviously, of 15 amps. Now we go through here. This wire over here. This wire over here, purple and orange. As you can see, these are striped. Then it goes through a connector, C156. Then it goes through a backup lamp switch. Right? The switch has to be transmission in reverse. We know you have to be in reverse for the reverse lights to go on. How many are there? There's 2 of them. L1, L2. One for the left, one for the right. Once you come out of that switch, the purple-orange will now be what? Black and pink wire with a pink stripe. And it goes through another one, C156 connector. It goes through another connector. Goes through a wire, black, again, black and pink, same one, but through a connector. Color is not changed. Another connector, color is not changed. Another connector, C350. Finally, we get to the loads, which are the lights. Again, black, pink, and again, black and pink. And then finally to our destination, which is ground. The ground goes back to the battery. We have a complete path. Now we're going to break it open and put opens and shorts. Let's start first with opens. Fuse blew on us. Okay. Over here, at this side over here, how much should we measure? Even if the fuse is blown. If you said 0, you're wrong. It should be 12 volts. Why? Because we're still connected to the battery. How much should we measure if the fuse is blown, okay, at connector C156? If this fuse is blown, we should measure 0 volts. Why? We are not connected anymore to B+. How much should we measure at C156 if the fuse is blown? There's an open right now. If you said 0, you're correct. All along this line, we are not connected anymore to 12 volts. How much should we measure at splice S335 if we have an open at the fuse? Right here. How much should we measure? If you said 0 over here, you're correct. Why? All of this will be 0. We are not connected anymore through the B+ at the fuse. How many lights will be on if the fuse is blown? No lights shall be on. Now, how much should we measure at C350, this connector? if we are in the drive position. If you said 12 volts, you're wrong. Why? This has to be in the reverse position. When we shift that gear has to be in the reverse. If it's not in the reverse, this is an open switch. If switch is open, everywhere from here to here will be 0 volts. The lights will not be on. If we're on drive, will I have 12 volts across here? If you said yes, you're right. Why? Because this is not blown. This is not an open circuit. Therefore, 12 volts here, 12 volts over here. How much should I measure at C156, which is the connector, if this is in drive? If you said 0, you're wrong. I am still connected to 12 volts through the fuse. Anytime I break the connection to B+, this is open, this is open, this is open, this is open. After that point, I will measure 0 volts. How much will I measure? Or, put it this way, L1 is out. On the reverse lights, when I put it in reverse, L1 is out. Can the other one work? Can L2 work on the right side? Yes, it can, of course. But why? Why can it work? Because I still have current flowing through here. I'm in reverse. Through here, through this connector. This is open. So current says, okay, I can't take this path, but this is a splice. That means what? There's another branch. If there's another branch, there's another path for this current to flow. It says, okay, fine. So I can't take this path, but I have another path. I'll go through the other one. Where does it go? Through this splice. And it goes back to ground. As long as it has a complete path back to ground. It doesn't care that this is out of the picture. Current doesn't care. So therefore, this can still light. What happens if I put another 3 or 4 lights across these? How much should they all measure? 12 volts. Anytime across another one. What happens, let's say now, okay, now this wire broke. Purple-orange wire broke. How much should I measure at these 2 lights? Will they be on? Will they be off? Remember, this wire broke. If you said both should be out, you're correct. Why? This is broken. This wire broke. When it broke, I'm not connected anymore to B+. Since I'm not connected anymore to B+, I can't measure 12 volts. I can only measure 0 volts. 0 volts through here. What about this? This is closed, even though I'm in the reverse position. I don't know that the wire is broken. I'm just putting the car in reverse. I'm going into a parking spot. The car that's in back of me is honking me like crazy, telling me, hey, your lights are not lit in reverse. I couldn't even tell that you're going in reverse. Right? You said, oh, okay. How do you know you're in reverse? Well, I like to take the car in back, and I like to look at the reflection of the lights at the car in back of me. When I say reflection of the car in back of me, I know that the lights are on. But I put in reverse, these lights are not on. What can be the problem? This is broken. That means 0 volts here, 0 volts black and pink, 0 volts here, no current flowing whatsoever. Both are out. Why? Because he's broken. Let's say splice is broken. Well, will the lights be on or off? Both lights should be off. What about the connector? C350 is open. I put C350, but you know what? I didn't connect it in fully. So what happens when you drive? You hit vibration. You hit potholes. And those connectors get bad. And I want to make the point, the printed circuit boards, the modules, the computer modules. Of course, the enemy is heat. The worst enemy for modules, for computer boards, is vibration. When I show you the boards, we're talking about surface mount technology. And these chips, which have to make a certain connection to the board, to the pads they're called. When there is vibration, or you're going 89 miles an hour on the highway, hitting bumps, there is vibration. Those components tend to come off the pads. That is the worst enemy for these computer boards. You can wiggle a connector all you want. You can drive it. When the driver drives it, when you give it back to the customer, the driver drives it, will hit higher potholes, bigger potholes, and those modules will not survive them. I'll show you the board in a second, but first we have to troubleshoot this. I hope you understand this a little better. Splice is open, connector is open. Will these be on or off? Both will be on. Ground just opened up on me. C350, another connector, not connected tightly enough. I'm driving and driving and driving, right? It came out, but I don't know that because I'm not in reverse. Then I go to park and I put in reverse. Again, the lights are off. I don't see the reflection on the car in back of me. What do? I said, okay, the lights are off. What could be the problem? Well, we know maybe the fuse. We know maybe this opened. The purple, we know maybe the switch is faulty. Maybe this wire open, maybe this connector open, maybe this connector open, maybe this splice is not making contact, right? But the ground over here is open. Current has no path to go back whatsoever. Current cannot flow. The lights will not go on. Go back to the example we had before. Look, we said purple wire is open. It just opened, right? It broke. In that situation where it broke, guess what? It broke and it made contact to the ground because everything around it is ground. Chassis ground, engine block, alternator, you name it, everything is ground all over. In that process, it opened. But what happened? Guess what? When it shorted to ground as an open, now it blew the fuse. So keep that in mind. Even though you have a wire that can open, there is ground all over. It is a ground potential all over. Like I said, doesn't mean it's a negative. You have to hit the negative of the battery because where's the negative of the battery connected to? Chassis ground, block ground, engine block ground, all over. On that body of that vehicle, there is ground. So once it hits, that's it. It can land anywhere. So now it's a short. It blows the fuse. Okay? If this would just open, the fuse would be okay. Right? Now let's go over shorts. This one is shorted. This wire, as an introduction, that's why I brought that up. This black pink wire, there's two, this is a connector over here. One to positive over here, one to one side, and one to the other side. Two wires going to each bulb, as you'll see. This one broke off. In the process of being broken off, guess what happened? It touched ground. It blew. Will it blow the fuse? Yes, it will blow the fuse. A direct short across the battery. Now, this one over here is broken. It broke. This one will not light, we said. But this one can light. Fine. Anywhere there's a short here, let's say L2 is shorted. Will current flow here? Absolutely not. Current takes the path of least amount of current. But what will prevent it? The fuse. Hopefully the fuse will blow in time before it does damage to anything. That's what you want. That's what you want. This. You want a fuse to act. Now, again, depending where the open is, depending where the short is. If this wire is broken, you see this black wire? If this wire is broken, let's say take this out of the picture right now. All right. Take this out of the picture. If this is open, I'm going to measure 12 volts over here. How much am I going to measure over here? 12 volts also. Chances are you're not going to take the bulbs out and go and measure 12 volts at each point. You're not going to do that. You're just going to look, are they lit or not lit? If they are both lit, you have something common to both. That means something will knock out both. What will knock out both? Without using a multimeter. Both lights are out and reverse. Can he be the problem? No, because you know why? He'll be open, this one could still light. We're not dealing with that. We're dealing with both are out. Can he be the problem when both be out? Yes, because he feeds both. Can he be the problem? Yes, he can. Can this wire be the problem? Yes, he can. Can he be the problem? Yes, he can. Anything that feeds both from here till back up here will cause both to go out. If he's open, he'll knock him out, but he can still light. If he's out of the picture, he'll knock both out. So first thing is first, always look, is one light on, is the other one on? If you have one, then it only affects that branch. If you have both out, something common to both. Now let me show you the boards that I was referring to. Okay, coming back to the video about modules, computer modules. Let's say a lighting control module. We're dealing with, this is a relay. We're dealing with chips. We're dealing with something called surface mount technology and through-hole. Through-hole is the old technology where you solder the components through the holes over here. The leads of these components go through to the other side. These are the leads after they have been cut off, the leads. These are the leads sticking out. These are the leads sticking out. This is the connector. These are the leads sticking out of the connector. That's called through-hole. These type are through-hole. These resistors are through-hole. Resistors, when they go bad, usually they open. These are the color-coded ones. These are the old technology where each color meant a different value of the resistor. I'm not going to go through over that. I did go over that one time. I'm just going to go over the basics. They don't usually short. They're usually open. The capacitors are usually polarized. Sometimes they're not polarized. Electrolytic ones are polarized. So therefore, one side will be the negative. When there's an arrow, it means it's the negative, and the other one is the positive. So you know which lead. There are two leads. It knows which lead is which to go into the hole. These usually have leakage. When they have leakage, they usually puff up. And you can see them, they get swollen. So usually these type of, they have a voltage, a working voltage, they call it. Where the working voltage, let's say, is 9 volts or 12 volts. Now, in my experience, people sometimes use a meter, sometimes use a multimeter. The working voltage could be, let's say, 12 volts, could be 15 volts, 20 volts. Just because you test it with a meter or multimeter, 9 volts does not mean that that capacitor is good at the working voltage at 20 volts. That is a false way to actually measure capacitors, these type of capacitors. There is an instrument that is used, a tester that is used to measure these accurately for leakage at the working voltage, meaning at, if this, again, 50 volts, if it's rated at 50 volts, it's hard to see it, but if it's rated at 50 volts, that's what you should measure it at. If you measure it with a 9-volt battery, that means it was tested at 9 volts. So what does that prove to me? Nothing. So these usually go bad. Now, these are called electrolytic, like we said. There are different types, ceramic, mica, and those things don't usually go bad, like these type of capacitors. Also, these are capacitors. Now, let's say diodes and transistors. These are diodes. These, you can see these are like called Zener diodes. And there are regular diodes. They're short or open or have leakage in them. And I've been working on these boards over 30 years of printed circuit boards. So therefore, I want to just explain, this is what the modules that are in your car are looking at. This is what it's composed of. Different types of things. Like we said, these are transistors over here. Transistors, they short, they open, base, collector, emitter. They have leakage in them. And these are through-hole. These are through-hole. These go right through. The difference now of surface mount that I was trying to say in the first place. These are now resistors. These take the place of those. These are resistors, small resistors. You have to solder these resistors. These are the pads that make contact. Hopefully, when I show you, I solder them and unsolder them, and then you'll see exactly what I'm talking about. So these are These are transistors. 3 leads over here are transistors over here. These are transistors making contact. These are old transistors, old technology. This is new technology right here. These are the yellow ones are the capacitors. These are the chips. Now these chips, you see this is a diode, a symbol for a diode. Problem is with these chips, and I have even smaller chips, these chips, the pins, these are called the pins. They go off the pads, making contact to the pads. Now, that's the worst enemy for these type of computer models is the vibration. Remember, you're going 80, 90 miles an hour, you hit potholes just because you tested that module. And you say, oh, it's good. Doesn't mean that the driver will drive it and it'll be good because he can hit bigger potholes than you, like I just said before. That doesn't mean anything. You have to know how to test and solder these boards correctly. Like I said, I've been doing this component level for over 30 years. These different types of modules, PC boards they're called. So, as you can see over here, these have to be changed. These are capacitors, the brown ones. Not easy technology to take out, but I'll show you the technique how to do it one day. Hopefully if I get good views from this one, if you want to see that. Again, these have to be reflowed sometimes. So when you're talking about heat is not the enemy. Vibration is the enemy. Where can you put it in the car that it will not, that it will be able to absorb the shock? Nowhere. Nowhere. Where are you going to put it? You put it, the PCM is usually on top, by the struts. Try to avoid the vibration. You can't even do that. There's nothing you can do. It's part of the vehicle. You're going to hit bumps, and these things, this surface mount technology, especially these chips, cannot take those vibrations. That's what I wanted to look at. Here's another board. Now, if you say that's a problem, this is the bottom of it. You can see there's one side with the components. Here's one side of a motherboard, a printed circuit board, computer boards. Again, these are potentiometers that go bad. These are the capacitors, electrolytic. Now these are electrolytic capacitors. See the positive here, the positive here. See the band? You know which one to put first. These go bad also. The chips that I was referring to, surface mount. Here is surface mount. Look at these. They all have to be replaced. This has to be replaced. Okay? Again, these are R7, however it says R, this is a resistor. R71 is a resistor. And these are capacitors. The brown ones are capacitors. So all that technology, that old technology, has been replaced by surface mount. This cannot take vibration. Not at all. Now look at the other side. Now the other side also has components on it. So you're talking about double-sided boards. Two sides have components on them, and these are all capacitors. Again, positive electrolytic. The band is positive. This is positive. C means it's a capacitor. Means it's a capacitor. As you can see over here, R means this is a resistor. This is a resistor. This is a capacitor. See? So therefore, I'm trying to tell you, you have to know how to solder these and how to take them out. Like I said, hopefully I'll make a video. If there's enough interest in this one, I will show you hands-on how to take them out, how to solder them, how to reflow them. You will not see this on any other channel. No other mechanic can do this to go component level on these type of boards. So when we talk about computers, when we talk about the modules, the lighting module, the fuel pump module, all